Okay, so what we're going to be looking at here is another example of an average velocity. And what we saw in a prior video was that an average velocity, v, can be thought as being equal to a displacement divided by some amount of time. Okay? Now, there's actually a little bit more to this equation when we think about average velocities, because as I mentioned previously, this doesn't tell you how you covered this displacement. It doesn't tell you if you kept it at like a constant velocity throughout, or if you started really slow and then sped up, or if you were moving very fast and then slowed down because you got tired. Okay? It just tells you you covered some displacement in some amount of time. This is your velocity. This is your speed with a direction. Okay? Furthermore, because of this, if we think about this to an even further example, if you imagine for a second that you're sitting in traffic, okay? So you're in a car and you're sitting in traffic. So here's your car, poorly drawn as always. There you are. And you're sitting in traffic for like 3 hours. You have not physically moved from this spot in 3 hours. So your velocity is 0 for 3 whole hours. That's a very long time. But then all of a sudden, all the cars in front of you disappear, and your car, you immediately slam on the gas, speed lines, and now you're moving at a velocity of like 100 meters per second. You're moving super fast, right? Like so fast. But you're only doing this for 1 second. What's your average velocity? Well, let me tell you what, it's not 50. Don't take 100 plus 0 and divide by 2 to get 50. That is not your average velocity. You spent 3 hours doing nothing. You spent 1 second going fast. Your average is a lot closer to this 0 than it is to the 100. Okay? So average velocities are a little bit different than thinking about just taking the two velocity numbers and dividing it by 2. Okay? So when we think about average velocities, what we'll actually do is we'll look at how much distance we've traveled every time and for how long we've traveled that distance. So if we take a look at this in this example down here, we're driving for 4 miles at 3 miles per hour. And then we travel another 4 miles at 50 miles per hour. What is our average velocity? So let's first just recognize that these miles here, these are delta x's, okay? They're a distance or a displacement that we're traveling through. And these 30 miles per hour and the 50 miles per hour, these are velocities. We're going to call these the first values and these the second values, just to keep them apart, okay? Now, in order to figure out the actual average velocity we have traveled here, what we're going to want to do is we are going to take all of our various displacements and divide them by the amount of time it took to do this. So this makes this problem a little bit of extra work for us, but it's not too bad. What we're trying to do is to find this average velocity. We're trying to sum up or add, and a symbol we can use for that is a summation like this, a sigma. We're trying to add all of the distances or displacements we've traveled, okay? And we're trying to divide that by the total amount of time that we've traveled here. So what this will look like is it's going to be delta x1 plus delta x2, and if we had more of these, it'd be 3, 4, 5, 6, 7, divided by the time it took us to go through the first displacement plus the time it took us to go through the second. Well, in this case, I have the delta x's. These are nice. They can just get plugged into the problem. But what I don't have here, which is a little pain in the booty, is I don't have these times. I have velocities, which means more work for me, but it's not a whole lot. If we go to the velocity equation, we see here that to get time, all we need to do is bring the time over and then bring the velocity underneath. So we're dividing by that. So in the end, our time will just be equal to a delta x divided by a velocity. And we can do that easily in this problem here because we have both the delta x and the velocity. So if we do this for our first positions in velocities here, we'll find that time 1 is just going to equal delta x1 divided by v1. And if we throw in numbers there, 4 divided by 30 is going to give us 0.133. So I'll just put 13. And that's in hours because that's what our units of time were in. And then if we do the same thing for t2 here, that's delta x2 divided by delta v2. That's 4 divided by 50, which gives us a time of 0.08 hours. So when we go and actually begin to put our values in to actually solve this problem, our average velocity here is going to equal the two delta x's, which are 4 miles for x1 and 4 miles again for x2. And then we're going to divide this by the two times added together, which are 0.13 hours plus 0.08 hours. If we do this math, remember we do our numerators and denominators first for our additions and whatnot. So I'm going to have 8 miles divided by 0.21 hours. And then if I just take 8 divided by 0.21, I find that my average is 38.1 miles per hour. Okay? And that will actually be our average here. That's what we're looking for. Okay? So that's what's going on here in these type of problems. They are a little bit tricky in that regard because there's an extra math step here, but this makes sense that the answer is 38.1 miles per hour. A person who didn't take a look at this video, they might say, hey, if you did the same distances, some at 30, some at 50, my guess is it's going to be 40. That's wrong. It's not just the split between them. Remember, you spent more time going slowly. If you were racing someone for 4 miles, you were going 30 miles per hour, they were going 50, it took you longer to travel that 4-mile distance. So you spent more time at 30 miles per hour, less time at 50, and that means that our average is going to be closer to the 30 than it will be the 50. So that's something to keep in mind when doing this. When we have, kind of changing velocities along that time interval, how could you find a true average based on that? So a little bit tricky of a problem, still totally doable. You'll want to check out the practice problem with the horses walking and a possible video with Cinnamon the horse. But for now, this is finished.